Video Lecture 3.4, Equatorial Low Pressure Trough. Like we've mentioned before, the equatorial low pressure trough is going to be found anywhere from 0 to 20 degrees north and south. We're also going to call this the ITCZ, and we'll explain why in the following slide. The equatorial low pressure trough is also known as the intertropical convergence zone, the ITCZ, and so if I use that term going forward, they're just interchangeable. They're the same thing. Intertropical gives a location as far as where we can expect to find this. Of course, equatorial does as well, but also convergence, it's a dead giveaway that this is also a low pressure area. One of the characteristics where we find here, we've talked endlessly about this, is the fact that we have the constant sun, consistent day length. Here we have that solar energy surplus. And so because of that, a low pressure starts to develop in this area. What we're going to find here is very warm, once again warm, also we associate with less dense, moist air that's converging with each other and then rising. So we have more warm, moist air converging and rising. This is all called the Hadley Cell, which I'll describe and show and illustrate on a following image. Key here is, because if you look at the equator, if you look at a world map of where the equator goes through, it goes through a lot of water. And so what you're going to be getting there is a lot of warm but also moist air that's converging and rising. And a key characteristic, we've learned this before, and is as we go up in elevation, temperature cools. So that eventually what's going to happen is that warm, moist air is going to rise, but eventually condense and, of course, fall back down as rain. And so here we can also find a pretty common situation of a lot of cloud cover. We've already talked about that in a previous video, and this explains why. It's because we get a ton of warm, moist air condensing, forming clouds, and then falling back down as rain. So in this area, the equatorial low pressure trough, the intertropical convergence zone, here we're going to have a ton of water vapor and a good amount of heavy rainfall. And so future lecture, we're going to look at the climate regions. So this area is where we also find the Amazon rainforest from a previous map quiz. Another characteristic that we're going to find in this area is the doldrums. And so the doldrums is used to describe when someone's depressed, they say they're in the doldrums. And this all comes to the fact that there's this low pressure area. And I'll illustrate this here in a following image as well. Real quick, explain evaporation and condensation. So in this image here, we have a puddle, or just let's say water on the surface. Eventually that water is going to be heated. It's going to then cause it to rise. And so essentially we've got the process of water going from its liquid state to its gas state, and that's evaporation. And eventually this water vapor, this gas, is going to cool as it reaches a higher elevation, condense, and then of course fall back down as rain, because eventually that water cannot be held aloft, which is why the rain falls. It's no longer capable of being held up in the sky. It's just weighs too much. To explain the doldrums, the left-hand side would say it's the northern hemisphere, the right-hand side is the southern hemisphere, and of course the equator right here in the middle. This is kind of from the side view. So of course we have our low pressure area. The doldrums comes from the fact that here you are, you're sailing, and you'd like to get across, go to the southern hemisphere, you'd like to go maybe to Brazil, go to Carnival and all of that, but you can't get across because of the doldrums, because of the converging air, and so you kind of get stuck in this place, which is once again a way to that's been used in normal language to describe someone who's depressed. They're in the doldrums. Here's our good friend, the Hadley Cell. The Hadley Cell, this is a cross-section, the side view with the surface. At the bottom, of course, the world is not flat, but it's a way I can showcase the Hadley Cell. At the top, because it's a side view, that's going to be the top of our atmosphere, or sorry, our top of our troposphere, where all of our weather takes place, and that's the Tropopause. What we have is the Hadley Cell. Some characteristics of it is we have low pressure areas here in the center, causing warm, moist air to be pulled together, converging, and eventually it's going to converge, it's going to rise, condense, and fall back down as rain. So also associated with the equatorial low pressure trough is that dense rain belt. But we know that this air continues on as it makes its way towards the poles. But like I've said beforehand, it doesn't make it all the way to the poles. And so what ends up happening is this air is essentially, it's dry. All of its moisture has been left behind in this equatorial low pressure trough. And so as it continues on, not only is it cool air, but it's dry air. But we also, like we showcased on the previous slide, the 30 degrees north and 30 degrees south also corresponds roughly with the subtropical high pressure. So it's actually the subtropical high pressure which kickstarts and causes the convergence that we find there along the equator at 0 degrees. And so this cell, this flow, is all called the Hadley Cell. And so the Hadley Cell is corresponding to the equatorial low pressure trough, that low pressure in the center, followed by the air continuing working its way towards the poles. It doesn't make it all the way, but then it descends and diverges. That makes sense. It's a high pressure in which we have that divergence coming back. And so it's just essentially we have a cycle that flows here. We can visualize the equatorial low pressure trough and that dense rain belt in this image here. And so if you look just to the left of the top of South America, just to the west there in the Pacific, you can see all that white. All that white in a very much a horizontal line illustrates convergence, the equatorial low pressure trough, and we know that this is probably in the U.S. summertime because this equatorial low pressure trough is a little bit more north of the equator, 0 degrees. And so this all moves back and forth throughout the year, which we can visualize here. So this would be more what we would see in that previous image where the equatorial low pressure trough, that intertropical invergence zone, is north of the equator. But like the subsolar point, like the changing of the seasons, this all migrates, and so it migrates throughout the different seasons, to the point where that equatorial low pressure trough now moves to the southern hemisphere. And so this all migrates throughout the years, which is key to understanding some climates in this area of the world. Here's a way to visualize the equatorial low pressure trough, the blue indicating heavy dense rain, total rainfall, and you can see that blue. You can see that how it's very much right there, especially over the water bodies, right there along where we would expect the equator. But then if you look just to the north and the south, especially on land, you really see that of that line, you see hardly any rainfall. So that corresponds to the subtropical high pressure, which is what we're going to talk about next.